Okay guys, so this is topic 4, the final topic of optics, lenses. So again, like the previous two topics, fairly short. Well, it's a bit longer than the others, 13 pages. But I'll see if I need to make 2 videos. We'll see. If this starts going over 20 minutes, I will split it. But we'll go through quick enough. No need to look at this stuff, you know it already. First things first, guys, know the difference between your 2 lenses now. Convex is also known as converging. Concave is also known as diverging. Convex, again, cave, the mirror or the lens looks like it's caving in. That's the way to think of it. Okay? So concave, it's caving in. So then, of course, the convex is the opposite. Converging is because when the rays of light hit this, it's going to bring them together. Whereas with this, when the rays of light hit, it's going to spread them apart. Okay? So that's why they're called converging and diverging. Okay. So, convex lens. All right? You have to be able to draw the ray diagrams. Again, similar. This time there's 2 focal points. They're on opposite sides of the lens. Okay. If it hits the pole, it goes straight through. That's an easy enough one. But then, like previously, if it goes in parallel, it comes out through the focal point. So therefore, what's the obvious next step? If it goes through the focal point, it'll come out parallel. So that's the easiest one to remember. If it goes in parallel, it comes out through the focus. If it goes through the focus, it comes out parallel. See? Comes out through the focus, goes out parallel. Okay? Now, for a convex lens, all right, outside the focus, you'll get a real image, okay? And the image will be inverted. If it's inside the focus or at the focus, you get a virtual magnified image. And the image will be upright, okay? So if it's a real image, it'll be on this side. So, no, a second. So, real image will be over here somewhere. And a virtual image will be on the same side as the object. So if the object is here, the virtual image will be here, and the real image will be there. Okay? That's kind of the basic idea of it. All right. Now, how do you form a real image? Something like this. So these are your diagrams here. All right? And then your virtual image is you're at the focal point, so therefore you see the lines won't meet. But if you're inside the focal point, you will get a virtual image at some point. Okay? So virtual image at or inside the focal length. The equation is the exact same as the one previously. However, previously, a concave mirror was this equation, or 1 over f equals 1 over u minus 1 over v. However, now it's the convex lens. Okay? Right. The symbols all mean the same thing. And the same with magnification. Okay, so they all mean the exact same thing. So let's have a look at the question then. So an object is 40 centimeters. Object is u, 40 centimeters from a convex lens, and the image formed, v, is 25 centimeters. What is the focal length? Easy. F equals 1 over u plus 1 over v. Sub in your 2 values, and we should, oops, that's incorrect. That is 1 over f. Okay. So that should give you, when you sub in your values, 1 over f equals 13 over 200. So we invert, which means f is equal to 200 over 13, which means f is equal to 15.38 centimeters. Now, is it a real or virtual image? Well, u is at 40, so therefore it is real. And there you go. Okay, so it's a real image because the object is outside the focal length. And that's it. Okay? Very straightforward. Okay? Right, so we will move on to a concave. So a concave, you will always get the following. It is always virtual and upright, okay? And it'll be diminished. So you can't get a real image with a concave lens. You can only get a virtual image, all right? As you can see here, it goes through the focal point, or goes through the pole, it goes straight through. Okay, this is the difference. If it's going as if it was going to hit the focal point, hence why the dotted line, it was going to hit the focal point, it'll actually go out parallel. So vice versa, if it comes in parallel, what's going to happen? All right, so if it comes in parallel, it'll go out as if it was going, it will go out as if it came from the focal point. Okay, so if it goes towards the focal point, it'll hit and come out parallel. If it goes in parallel, it'll come out as if it came from the focal point. Okay, so therefore it's a minus u and a minus v and a minus f. Okay, because the v is always on the wrong side and it's always going through the wrong focal point. Okay, all right, and the magnification is the same. All right, so I have, let me see, 1, 2, 3 questions here. So these 3 questions are, the first 2 are very straightforward. The third one is a bit difficult, and then problem 5 and 6 fairly straightforward as well. Okay, so we'll go through these two. I'll go through them quick because the third one is a bit difficult. Problem 4. An object, sorry, turn on the VO pen, is 30. Focal length is 20. Find the position and the nature of the image. Well, because it's a concave, it's obviously nature is virtual. So we know that straight away. So we got to get find the position in nature. That's very straightforward. 1 over u minus 1 over v equals minus 1 over f. We're trying to find v. 1 over 30 minus 1 over v equals minus 1 over 20. Minus 1 over v equals minus 1 over 20. Minus 1 over 30. So 1 over v equals, what did I get there? 1 over 12. Therefore, v equals 12 centimeters. There you go. Okay, so we already know it's virtual. So there we go. That's it. All right. Now again, why people get this wrong is they forget. They always say, well, minus is virtual. I got plus. It's real. No, it's a concave, so it's always virtual. All right. Problem 3 then. An image 1/3 the height of an object. So an image v 1/3 the height of the object, formed in a concave mirror lens, focal length 60 centimeters. Find the distance u and image v from the lens. Okay. So v is equal to 1 over 3 u. So there's two ways you can do it. You can find u first using what I did before, or you can find v first. So for example, you could say that u is equal to 3v. Okay, and solve it that way. It doesn't really matter. Okay, so 1 over u equals, not equals, apologies, minus 1 over v equals minus 1 over 60. So if I go this way first, what I say is 1 over u minus 3 over u equals minus 1 over 60, minus 2 over u equals minus 1 over 60, 2 over u equals 1 over 60, u equals to 2 times. Sorry, I meant to get rid of the minuses there. That's what happened there. Sorry. So u equals 2 times 60. U equals 120 centimeters. So that's my object distance. U is 120 centimeters. We then find v. We say v is 1/3 of u. So v is 1/3 of 120. So v is, of course, 40. And there you go. You could have done it the other way, guys. You could have said u is equal to 3v. And you sub your v value in up here and you get the same thing. You would end up with v equals 40 and you just multiply that by 3. Done. Okay? So again, fairly straightforward. This one now, however, is a little bit difficult. Okay? So I have a lot of space on the notes for it. So I'm going to read the question and then going to roll it down and draw the diagram. Okay? And then I'm going to be rubbing things off and on, okay, as I do, because I need the space, okay? So you can always just rewind the video back, all right? So an object and a screen are fixed at a distance of 80 centimeters apart, okay? So we'll have our object here, that's u, and a screen here, and the screen is, of course, v, and we have our lens in the mirror, okay? And a convex lens in the center. So this is 80 centimeters. Form the real image on the screen. Perfect, real image. We got to remember that. All right. When the lens is moved along its axis distance of 16 centimeters, we form another one. Okay, so it's up to you which way you want to move this object here. So I'm going to call this u again. Now, what I did this time, again, the distance is still 80 centimeters, is I moved the lens 16 centimeters towards the virtual image. If you wished, you could have moved the lens 16 centimeters towards the object. Doesn't matter. You'd still get the same answer. Okay? So I'm going to call this P1 and I'm going to call this P2. Position 1, position 2. Okay? All right. So what I'm going to say here is F is the focal point. So F equals F. So for P1, all right, it's a real image. So 1 over U plus 1 over V equals 1 over F. Okay? That's basically it, really, isn't it? That's all we have. Okay, and we can say V plus U equals 80 centimeters, and we'll call that. So now again, You can do either one. You can either, what are we looking for here actually? Find a focal length of the lens. Right, so you can either have u equals 80 minus v, or v equals 80 minus u, either one. Again, you will get the same answer in the end. I found v first, u equals 80 minus v, okay? And I call that 2. Now for P2, what do we have? We have, our distances are changed now, okay? So we still have 1 over f, focal point is focal point, that doesn't change. But u, okay, is now 1 over u plus 16 centimeters, and v is v minus 16. Why? Because we move 16 centimeters towards v. So the distance for v is less, but the distance for u is more. So if you did the other way around, you would end up just doing the other way, that's all. All right, and we call this equation 3. Okay? Now, f equals f, therefore 1 over u plus 1 over v equals 1 over u plus 16 plus 1 over v minus 16. All right? Okay, so there we go. Now, this is where this comes in for 2. Okay, I said u. Now, if you wanted to, you could have said v equals 80 minus u and found that and go back. It doesn't matter, guys, which way you do it. And again, it doesn't matter up here. If you move the lens towards the object or the screen, you will get the same answer. That's the thing about physics. There's usually more than one way to do it. This is just one way to do it. If you want to test yourselves, try do it moving the lens the other way. It should still work out, guys. Okay? All right, so now we got to get rid of an unknown because we have 2 unknowns. You can only have 1. So I'm going to sub in 2. So what is that going to give me? That's going to give me 1 over 80 minus v plus 1 over v equals 1 over... Right, so 80 minus v plus 16 should give me 96 minus v plus 1 over v minus 16. Okay? Because I put in, that's 80 minus v for u, you see? So 80 plus 16 is 96. That's what's happening there. Okay. Now, so we got to get the common denominator for both sides. Okay? So the common denominator on this side is going to be 80 minus v. Yeah? Because they both have v, so this one has 80. No, actually, no, what you do is we'll multiply them 2 together because you've got 2 different numbers. Apologies. So it'll be 80 times. So 80 minus v goes into 80 times v times. Okay? And v goes into v times 80 minus v, 80 minus v times. On the other side, we'll multiply our 2 numbers together. Okay? So this goes in v minus 16 times, and this goes in 96 minus v times. Okay? So again, that gets rid of that, that gets rid of that, and that gets knocked down to 80. So we're left now with 80 over v, 80 minus v, equals 80 over 96 minus v, v minus 16. And it's here where most people say cross multiply, okay? Which you can well do that. You could cross multiply, bring this up here, bring this up here, okay? And then you start multiplying it out and you whittle it all the way down, okay? That's perfectly fine. You are well entitled to do that. You would be correct. I'm going to show you a little trick to make this a lot easier, okay? Because if 80 divided by v times 80 times v is equal to 80 divided by 96 minus v times v minus 16, then that means v, 80 minus v, is equal to 96 minus v, v minus 16. Where am I getting that? Simple. If 4 over x equals 4 over y, they're the same, then that means x equals y. Okay? If 4 divided by x gives you the exact same number as 4 divided by y, then that means x and y have to be the same. Okay? And that's kind of what we're saying here. It's just to make it a lot easier, instead of trying to cross multiply, there's numbers flying everywhere. This gets rid of a lot of numbers straight away. Okay? If the top line of both sides are the same, then that means the bottom line has to be the same. They have to give you the same number. Okay? All right? Just a little trick. All right? And now another way to think of it is if you do cross multiply, you could divide that into that and get rid of it. Okay? So that's another way to think of it. All right? So v, 80 minus v, equals 96 minus v, v minus 16. Okay. Now, multiply all this out. So this is going to be 80v minus v squared equals 96v minus, let me see now, 16 times 96 minus v squared plus 16v. Yeah, okay. So 96v minus 16 times 96 minus v squared plus 16v. Now we can see that on both sides the v's cancel off. Okay. Now how much space do I have left on this? Okay, not enough. All right, so what I'm going to have to do now, guys, I'm going to rub out this top bit. I'm going to leave this line here. I'm going to cut a line here, but I'm going to have to rub out the rest. Okay, so we can bring back the YouTube video. So this is where we're at. Okay, we're left with the final line. 80v is equal to 96 v minus, where's my calculator there? I never calculated this out. 16 times 96 equals 1536 plus 16v. So that's where we're at. That's where we got to. Okay. So I'm going to rub out all the rest just because I need the space. I'm going to have to move it all the way back up. All right. So by making the two sides equal to each other, cancelling off the 80s, I just made life an awful lot easier. All right. Okay. Again, you can always just bring the YouTube video back. All right. All right. So I left off at, I'm going to rewrite that out now. So 80v is equal to 96v minus 1536 plus 16v. Okay. So I'm going to bring all my v's to one side. So I'm going to rub this out here now because I don't need that anymore. All right, so I'm going to bring all my v's to one side and I'm going to leave my number on the other. So 96 is going to come over and 16. Was that a plus or a minus 16? Sorry, let me double check that. It was a plus. Okay, that's going to go over. So we're going to have 80v minus 96v minus 16v equals minus 1536. So this will become 32v minus 1536 equals 1536. So v simply equals 48. Okay, so v is 48. And if we look up here, we said u is 80 minus v. So therefore, u 80 minus 48, which means u should give us a value of 32 centimeters. Now the question was to find the focal length, I think. Yeah, find the focal length. So therefore, we sub that in. 1 over u plus 1 over v equals 1 over f, you see. Which means we're now going to have 1 over 32 plus 1 over 48 equals 1 over f. And that simply equals 80 over 1536. Okay. And therefore, if we invert that, f equals 19.2 centimeters. Okay. So we have f. And the last thing then was find the focal length and the magnification produced. Okay, so the magnification produced then. My God, this thing's not picking up the rubber at all. All right, so the magnification. Now we had two positions, so we have to do magnification for both. For P1, okay, m equals v over u, which is very straightforward. That's going to be 48 over 32, which equals 2/3. 3 over 2, not 2/3. For P2, same thing, except this time m is equal to 48 minus 16, 32 plus 16, which gives us 2/3 this time. And there you go. That's it. And you're done. Okay. So that was a long, awkward question. It was just long, not awkward. Max numbers flying everywhere. It's just set it up. Oftentimes, guys, draw the diagram. It'll make it a lot easier for you. Okay, so we're hitting 20 minutes now. Now I'm going to keep going because there's literally very little left. I'll be done in 5 minutes. It'll be a little longer, maybe half an hour video. Okay. All right. So the last thing to look at here, guys, is the power of a lens. So power of a lens is 1 over the focal point, P equals 1 over F, okay? However, unlike the rest of optics, you have to change to meters because power is per meter, all right? So you're gonna have to change your focal length to meters. So you'll find your focal length in centimeters, convert it to meters, and you're done basically, okay? All right. Now, if two objects are in contact, the total power is equal to P1 plus P2. So therefore, you can find the focal length from that because obviously F is 1 over F is equal to P, all right? And remember that your convex gets a positive lens and your concave gets a minus because concave is diverge. So it's going to spread the rays out, and this is converge. So it's going to bring the rays in, okay? Problem 5. Find the power of a convex lens of focal length 40. Very straightforward. P equals 1 over F. F equals 0.4 meters. Therefore, P is equal to 2.5 meters. We have to convert. And a concave lens of focal length 60. So F equals 0.6. P equals 1 over F. P equals minus 1.67 per meter. Why did I have minus down there? Because concave. Okay, so its power is minus. So concave has to be minus. All right. The last question in this topic. Okay, so an object, a height of 2 centimeters. So HO, 2 centimeters, is placed 20 centimeters, U, 20 centimeters, from a lens combination consisting of a convex lens of focal length 10, so convex, F equals centimeters, and a concave lens, F minus 15 centimeters. Find the position, the nature, and height of the image. Okay, so we have two lenses in contact. Okay, so we need to find the total power. So PT equals P1 plus P2. Okay, P equals 1 over F. Okay, so therefore P total is equal to, I'm going to make this lens 1, this lens 2, 1 over 0.1 minus 1 over 0.15. Okay, why? Because you have to convert to meters. Okay. All right, so my total power, therefore, should work out to be power total, I'm going to just bring it over here, equals 3.33 meters. Okay? Let me see, did I do that right? Yep, so it should work out to be 3.33 meters. All right, so therefore our total lens, P equals 1 over F. So therefore, F equals 1 over P. All right, so F here equals 0.3 meters. So therefore, F equals 30 centimeters. Oh, all right, so why am I doing this? Because we're trying to find the image. Okay, apologies. All right, so if you ever see the two lenses, you start with this to try to find the focal length. So that's the total focal length of the two combined lenses. Okay, that should be an F. That doesn't look like a very FEF. All right, so the total combination, the focal length of the two lenses in contact is 30 centimeters. Okay, all right. Now that we have that, we can now find everything else. Okay, because it's positive. Okay, so what does that mean? All right, so therefore it acts like convex. If we had a negative number there, it was a concave lens, but it's a convex. So we can use this equation, 1 over U plus 1 over V equals 1 over F. We said U was, what was U? Let me go back. 20 centimeters. 1 over plus 1 over V equals 1 over 30. Okay? All right, so 1 over V equals 1 over 30 minus 1 over 20. V should equal minus 60 centimeters. Okay, so we have a virtual image. Okay, so we have a virtual image. That's the first thing we found out. It's minus 60 centimeters. It's on the same side as the object, and it's a virtual image. Part 2, we want to find basically the magnification. So magnification is height of the image over height of the object. Okay, so what was the magnification? Find the position, nature, and height. Okay, so they didn't give us the magnification. So we're going to have to figure out the magnification. So M equals HI over HO, which is all equals V over U. We have a V over U, height of image, height of object equals, what was V? V is 60 and U is 20. Okay. Now again, you ignore the minus. Well, you can leave the minus in. It doesn't. You're going to end up with a minus image in it, but you can leave the minus out because the minus just says where it is. But we're dealing with the height now, so you can leave the minus out. We know it's a virtual image, but you can leave it in if you want. It makes no difference really. All right. So height of the image is going to be 60 over 20 times what did we say the height of the object was? 2. So the height of the image should work out to be 6 centimeters. And there you go. And that's it. Okay, done. So we found all the 3 things that they wanted. The virtual image minus 60 centimeters. The very last thing here now, guys, not a maths thing, just a theory thing. The eye, the parts of the eye, you need to kind of know. For physics, the key ones really is the retina is where the image is formed. The pupil it's the liquid sac that changes the size. Okay, so the light is going to come into the eye, and this is going to refract it and try to get it back to a certain point on the eye, so it can form the image. That's the idea of it, basically. Okay, so the eye has what's called the power of accommodation, the ability to focus a real image of an object on the retina, whether the object is near or far away. Okay, so if you are short-sighted, you need to know this though. Okay, so short-sighted, you can see in your eye but can't bring distance object into focus. We need a concave lens. If you're short-sighted, you need to get a concave lens. Okay, the reason being is that the image is forming inside the retina. Okay, so you wear this lens and it spreads it out. So then a long-sighted is the opposite. So long-sighted, you can bring distance object in. A lot of people who are old, as you get older, you suffer from long-sightedness, where you can't read books and stuff because it's too close to your eyes can't focus it in. So that's where you have reading glasses, okay? So you get a convex lens because your image is forming at the back of the eye, and that's it. That is the end of optics, guys. Hope it's helpful. As always, leave questions in the comment section on the Edmodo page.